This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software.
Hi, this is Priyanka Raghavan for Software Engineering Radio, and my guest today is Sam Scott, who's the CTO and co-founder of Oso, where their mission from LinkedIn and several other blogs say, we're making security easier for developers. Sam holds a PhD in cryptography, and he regularly writes on authorization and has also appeared on several podcasts. Today, we're going to be talking about how to build a consistent and global authorization system or service and subsequent challenges. So welcome to the show, Sam.
Thanks for having me. It's good to be here.
Is there anything else you would like listeners to know about yourself before we jump into all things authorization?
I think you about covered it. I mean, I guess, one other thing is I've been myself coding for about 10 years or so now. One big changing event for me was when I discovered Rust. I'd actually kind of resigned myself to not be a decent programmer, and I thought I'd maybe stick in academia and research, but kind of found Rust, and that unlocked a bunch of things for me.
We're definitely going to ask you a lot more about that soon. But, let me just take you a little bit through SE Radio, right? Software Engineering Radio. We've done a couple of episodes on securing your APIs. We've done an episode on OAuth 2. We also had a show on Open LDAP, but we've never really focused a show just on authorization. So I thought, we could start right from the top, where maybe the first question I'll ask you, which maybe is oft repeated, but what is the difference between, say, authentication and authorization? Can you define the terms for us?
That's a great question, especially because a lot of the time people just say auth and they sort of maybe mean either one. So it's good to clarify. So authentication is the process you go through of identifying who somebody is. So typically this means, you log in with username and password, or you maybe log in with a social login, Facebook or Google. But it's kind of that process through which, the website identifies who you are. On the other hand, so authorization is kind of the bit that comes next. It's like, now that I know who you are, what are you allowed to do? Those are kind of the two pieces. And what gets really challenging here as well, you just touched on a few technologies like OAuth and LDAP, where it starts blurring the lines between the two a lot. I mean, OAuth is technically primarily around authorization in a sort of a different context. It's granting consent to other people to access your data on your behalf. Also used sometimes for doing authentication, like, can I check you have this identity? And the two terms get very, very mixed and very interchangeable.
Okay, so maybe then you can break it down. Another terminology which is often seen in literature is RBAC. What is that? Can you define that?
Yeah, so RBAC stands for Role-Based Access Control. It's a pretty broad term. It captures the sort of the idea that, instead of just saying directly, like, what can a user do? You sort of group a bunch of users together under like a role, that's what it's called. You basically define what that role can do instead. And so you imagine, you have a website with like millions of users. You maybe just can sort of segment them into two different user types. You have members and admins. Those might be the two different roles. And then it's like pretty easy to say members can do X, Y, Z, admins can do A, B, C. And so it's kind of a way of structuring that authorization logic.
You said you have a group of individuals who belong to a particular role, and then you can give them what can they do, like, on a resource, Would that be right?
Exactly, yes.
So another thing that I see is, especially when I was researching before talking to you, was there was another term called RBAC, which is relationship-based authorization. So can you also define that?
Yeah, so in some ways you can think of relationship-based access control, RBAC, as a more general version of role-based. So instead of just saying, grouping users by a role, you start saying, well, like, what other kinds of relationships exist between things? Maybe it's users and resources, or resources and other resources. A simple one might be most websites, if you post a comment or something, you can normally also delete that comment or maybe even edit that comment, but most users can't. And so it's kind of saying, well, you have a relationship with that comment. You're the one who submitted the comment. And as the submitter, you're able to, make certain changes. And it's kind of like different versions of that. So maybe you have a good example would be like in a Google Drive-like system, you have files belong to folders belong to other folders belong to organizations, like all of those are relationships between the data. And so it's kind of like different forms of relationships there. It's like, maybe it's a user to a resource, you create a document, it's a resource to another resource, a document belongs to a folder. you maybe throw a role in there as well. And it's, you're an admin of a folder and the document belongs to the folder. You can do certain things. I think this kind of separation between the two is a relatively new thing. Like a lot of what I just described could also sort of be broadly captured in the RBAC, in the role-based paradigm. Like it all sounds similar. Like, oh, I'm an admin of the folder and the documents in the folder. Like sounds very rolesy. But I think kind of go to actually a little bit of granularity and saying, well, actually we're describing something unique here by describing this like file system hierarchy is what RBAC's about.
Great. Another term to add to this picture is the authorization model, where whenever I read a lot of articles or papers, they talk about how important it is to have a good authorization model to enforce things. So can you maybe define that? So all of this, do you put that into an authorization model?
Yeah, absolutely. So the way I kind of think about it is, to start with, the way I described authorization is this entirely open-ended question. Who can do what? It's like, okay, like where do I begin? So the idea of authorization models is really just sort of identifying patterns that are very, very common out there and sort of giving you a little bit more structure on how you go about answering that question. And so really what it allows you to do is sort of say like, if your app fits this kind of a shape, like if you are building a B2B app, you will probably want to use role-based system, like very, very commonly, and, you should think about it as users have a role inside an organization and they can do these things. You've sort of taken this problem, which is entirely open-ended, completely open to someone to solve however they want to, into something which is like now has existing patterns, existing templates, and like gives someone a little bit more structure to approach it. And that's kind of what a model is about.
So once you have a model, I guess it becomes easier to make decisions or enforce policies. Or would I be right in saying that?
You touched on a few things. Like you can kind of break up how you go about implementing authorization into a few different pieces. So the way we talk about it is there's kind of a separation between enforcement and decisions. Mm-hmm. Enforcement, it's the lines of code you add inside your app that kind of ultimately, do you show a page to a user or do you redirect them to an error page? That's kind of like the enforcement piece. Like, what do you do once you know if a user is allowed to do something or not? The decision piece is like, how do you make the decision if they should or not? So like, how do I answer the question, is this user allowed to see this page or this document? When we're talking about that kind of like decision mechanism, that's really where those authorization models come in. It's like, how do I go about answering that question? Like, what am I trying to get to? The policy piece that you touched on plays into kind of the specifics of how you actually implement that decision mechanism. Like you might say, okay, I want roles. How do you want to implement that? You could, use a roles library. You could use a policy engine. There's kind of multiple different approaches.
I think I understood that. It's very important to make that distinction. Okay, that's great. So let's, now that we've got the definitions out of the way, maybe we can do a little deep dive into, say, one of the main parts of this podcast, which is also about the Google Zanzibar system, which I think we'll jump into. But before that, we had the traditional way of doing authorization was, say with LDAP, where you have a group of users belonging to one particular part of the org, and then they are given access to a resource. How does that differ from, say, what, I don't know if the right term is to call it new age authorization, or maybe it's been around for a long time, but new age services that focus on doing authorization? How is it different?
That's a great question. And in some ways, it kind of comes back to what I was saying earlier, authorization, it kind of does cover a lot of different topics. I think what we've seen has changed, in the last, several decades really, there's been a huge shift from a lot of software development being done like in-house, internally inside organizations, or lots of IT being really an internal thing, into, the explosion of like software as a service and people building software products. And that's kind of the shift of authorization models. Like, so, things like LDAP, Active Directory, those kind of technologies, it's an interface for managing and assigning users to permissions, to groups, to roles, things like that. The focus is on like, I have a set of users. How do I, give them the right permissions? How do I group them together, assign them to resources, things like that, which makes sense for like internal IT team inside enterprise. You need to give the sales team access to the sales folder with the sales reports, things like that. When we talk about the kind of new authorization systems, we're talking about a different set of people. We're talking about, developers building applications for their end users. Those are now like multiple organizations, not just one organization. And so in some ways, what we're talking about is how do people build things like LDAP into their apps? So LDAP is it's an existing product that's integrated with different systems, but now it's like, well, you're building your own app. How do you want authorization? How do you want users to manage things inside your application? So if someone enrolls, you create a new organization and they want to add people to groups, what's their experience? And LDAP wasn't really designed to be used in that way, that it'd be embedded in other products. And in other ways is not the easiest thing to use. So it's not something that people have jumped to try and integrate into their applications.
True. We can now jump into a little bit into the Google Zanzibar project, right? And I think in the show notes of this podcast, I will add a link to the paper that came out from Google. There were several things that stood out in the paper, but maybe we can take it one by one. The first thing, what I wanted to ask you was, maybe you can tell us a little bit about the Zanzibar system before we jump into a few things. Can you just talk a little bit about that?
Sure. So Google Zanzibar is the name of a system developed at Google. They released a paper on this in about 2019, I think it was. It's a central system for how Google does authorization across their entire fleet of applications. So, everything from, Google Drive and Google Documents to, YouTube, for example. And it's a phenomenal piece of engineering. There's two pieces that I love to call out as the real core innovations. I mean, one is the sort of the mind-blowing scale that needs to happen for Google to do authorization at Google for all those services, right? But I think the second one touches on what we were speaking about earlier. It's, as far as I'm aware, it's kind of one of the first kind of really publicly spoken about implementations of relationship-based access control. I think people have spoken about it in the context of social graphs like Facebook previously, but I hadn't seen anyone who'd written about it in quite such a sort of B2B focus oriented way like they had at Google. So it's kind of those really those two core pieces, the model that they spoke about and they shared, and how developers at Google build apps with the system. And then there's just the feat of engineering to make this thing scale.
Mm-hmm. So I think they refer to something called as a relationship tuple, and I think there was another thing called namespace configuration. Being from a mathematical background, I'm sure you understood that piece where there was a lot of scary equations. But I think essentially it was describing the relationship tuple as well as I think how they grouped that under namespace. Maybe you could just give us a little intro to that.
Yes, I have a background in academia, but I had to read that paper numerous times until it finally kind of fell into place. It's not a light concept. It's a really interesting system. So, I mean, to start with the problem it's solving, we spoke about RBAC, relationship-based access control earlier, and I said, it's a file belongs to a folder, a user has a role for a folder, a document is inside a folder, things like that. A lot of that is the important stuff there is the data. Who has what role for what, and what folder does this file belong to, and things like that. And these are very varied data sources that can look completely different. They can be stored and managed in multiple different ways. So if you want to start thinking about how do we write a consistent abstraction over all these kind of things, you have a really hard problem on your hands, because you now have 500 different teams across Google writing different applications for different purposes, using different backends and so all these kinds of things. And you're trying to say, well, actually, no, I want to be able to say that there is just one single way of doing authorization. There's one consistent way of doing authorization. And so the way that Google went about solving this is they basically first came up with a kind of unified data format. And that's those relationship tuples. They basically said, we're going to have a storage engine for that data. And this is going to be the format. It's basically going to consist of three things: the subject, the predicate, and the object. So the subject would be the user. The predicate would be the admin role, and the object would be a folder. Because pretty much all relationships, you can kind of think of them like a graph. There's you sort of draw a line between a user and that folder, and the value on the edge would be the admin role or something. Or, file to a folder, and that folder is the parent or something. And so they kind of said, well, we're just going to take all of that data, and you just need to send that data to us and put it into this format. And now what we have is just one data store that has all of these different data formats in one consistent way. Now that we have it in this format, we can basically build an authorization system on top of it. And that's kind of where the namespace configuration piece comes in. It's basically a configuration format for developers to tell this central system, kind of telling them like, what does this data mean? And like, how do you combine it and like compose it together? So, the kind of thing you might say is if you're an admin of a folder, then you're an admin of any file inside that folder. And so the configuration format kind of allows you to express that kind of logic. Here's how you kind of take those data pieces and kind of combine them together. Putting all that stuff together, you now have like the core of this authorization system. It's not fully the way to authorization, but it's like a long way there. It's like, what relationship do I have with this piece of data? Mm-hmm. This authorization engine can basically take the configuration, can take all of its data and do that expensive computation. Like, recursively, this file belongs to this folder, this folder belongs to this folder, this folder belongs to this organization. Oh, and this user is an admin of that organization. So tracing all that through, doing that recursive query, I can figure out that like, yes, you are an owner of this file. And voila, your Google document opens and, you're allowed to go and edit it.
The other part where, that Google document opening quickly is also a big thing. I think the thing that fantastically stood out in that paper was, of course, the scalability challenges and the numbers that they threw out there, right? Like, just to quote a few of it, I have to read it from here. I think it said something like 1,500 namespace, which is defined by hundreds of clients. And there were 2 trillion relationship tuples of about 100 terabytes. And it was able to handle 10 million client queries per second. So in this regard, I wanted to ask you your take on how important is it for a good authorization system to place importance on, say, scalability and consistency?
I mean, those numbers kind of speak for themselves, right? I mean, if you think about the volume of data is not surprising when I just, spoke about what it consists of. Files belonging to folders, users having roles, like a lot of that is really core application data. And so you're saying, this is a central data store that is handling a big chunk of Google's data, and that's why there is 10 trillion, whatever it was, relationship tuples. Mm-hmm. That's, data basically collected from every app at Google. And then you think about the 10 million client queries per second. Authorization is something that is happening on, or should be happening, once, if not multiple times, on like every single request that goes to any application. Like anytime a user reads a piece of data, you should be checking, are they allowed to read that? Anytime they try and do something, you need to be checking, are they allowed to do that? For any application, authorization is always going to be this piece that is effectively kind of a fixed cost on the scale of your application. It's like not something that just, it's painful at a certain stage. It's like, no, it's always going to be expensive. And it's pretty common basically for any team that like authorization is going to be this like hugely impactful performant piece of their app. And I think, basically what Google did by putting this all into one place and being able to measure is you can kind of see the impact of that.
Full disclosure here. So at my day job, I also have been working on building a kind of unified authorization service. We're on iteration 2 right now. It's tough. Trying to build something generically is challenging to say the least. So in your experience, should you build your own authorization service or should you repurpose something? Any advice on that?
The challenge is there really aren't that many existing solutions out there. I mean, that's obviously something that we're trying to change, that we're trying to address by building stuff. And there's a kind of a few other people out there trying to do the same. The challenge a lot of people face that we've spoken with is companies rather share like 80% of like kind of the same logic, the same core pieces. And that stuff you could maybe try and like standardize, or you could build like one product for and solve. But everybody has their own like 20% of like special, unique to their business, things they need to handle, whether it's like some billing based logic where if you've paid for a certain tier, you get access. Maybe it's around like usage quotas. Maybe it's around, I know you have a specific like collaboration and sharing model. Like everyone has these unique pieces. And so it can be really hard to find something like off the shelf that like just works. You take something like a Zanzibar, and as I was saying earlier, it gets you like a lot of the way there, but it doesn't actually even like fully solve your problem. I think the key problem that like a Google Zanzibar solves is performant data lookups over like very relational data, very like hierarchical nested data, especially if you want to do that across like multiple applications. It's like one of the things that Zanzibar was needing to solve was like, might get the specifics wrong of this, but it's like if you're embedding a YouTube video inside a Google document, then you might still need to do authorization on the YouTube document and the Google document and like kind of do those things together. And so get kind of like messy and nested. But that's like one big piece that Zanzibar is going after, but it doesn't kind of actually help you go do that like final piece of what different permissions do you have inside a Google document? And like, what can an editor or a document do versus what can a viewer can do? And like, what should the user interface look like? Like, what pieces of data should we show to the user? Like, should we tell the user if they can do this or not? The challenge with authorization is there are like so many different parts of the problem to solve that cut across so many different parts of the stack that it's sort of hard to talk about, like, do we build an authorization service or not? Like, should someone solve this or not? It's around finding the suitable pieces to attack like the different parts of the problem you have. Zanzibar, I think specifically, is very good at solving that, like scaling authorization for deeply hierarchical nested data at like a global scale. But it's also not like a template to build something and solve all your problems.
What I'm hearing is there's just not any one magic bullet for your authorization challenges.
Not yet, unfortunately.
Yeah, you have to go through the hard task of actually building the relationships and trying to work it out. I guess the modeling is super important before you jump into any implementation and enforcement.
Mm-hmm.
So now I guess I should move on to the meat of what we're here to talk with you about, which is Oso. What is Oso? I did read on Twitter that Oso means bear in Spanish. What's the inspiration and how does that tie in with authorization?
Yep, Oso is indeed bear in Spanish. The name came about, I mean, honestly, because, so you mentioned this at the very beginning, right? Like, what we're about as a company is making security easier for developers. And when Graham, my co-founder, and I were like coming up with names, I kind of had like one requirement. I was like, I don't want to be named like all those other security companies that sound scary and intimidating, and they always have like some security name in them, or fortress or things like that. And just they really kind of want to feel like they're selling you on like this, you know, we're the secure solution, you need to be scared and trust us. Like, that's not what we're about. We're about like making security more accessible for developers, empowering them, giving them tools that help them like take away the bits they don't want to solve and kind of makes it easier for them to build. And so that was my requirement, was that we had something that was kind of a little bit more friendly and accessible. It happens that Graham and I both speak Spanish. And so I don't know, we wanted something that was like kind of easy to remember and easy to spell, and randomly came up with Oso and just kind of fell in love with it.
Okay. So what can Oso do?
Yeah, so Oso is an open source framework for authorization. And the kind of core of it is helping you figure out how to build authorization into your application. A few core pieces of this. We've touched on a lot so far, but so we have, for example, a policy language called Polar that has a lot of like kind of building blocks and built-in pieces to help you with that modeling piece. So for things like roles and relationships that we've touched on, we have like specific patterns built into that to like help you get started and to say like, here's the backbone of your authorization model. Here is, you know, that 80% that you should just kind of do because it's the best practice, and like kind of, you know, we'll give you that piece. The policy language piece of it means it's like super flexible to do all those kind of like extra custom things you're going to need to do. You know, you can, you know, if this thing is public, you can see it. And if the, you know, whatever, this was created in the last 10 days and you can't edit it, or, you know, whatever the custom logic needs to be, like the policy engine can help you do. And so that's like on the modeling front. We support like a number of different languages, and we have a kind of a bunch of enforcement APIs that really helps you with the, how do you actually make and integrate authorization like into your application? Like, how do you make sure you're turning the right piece of data? How can you know, make sure you're taking the right action at the right time and kind of making sure you don't get anything wrong?
So you talked about patterns. What is that? Can you just explain that a little bit more? What do you mean by patterns?
So we have this concept of a resource block. The policies you write with Oso are very resource centric, because a lot of authorization tends to be like, can I see this thing or not? And so we have, you know, syntax built into the language to express, hey, I have a resource. These are the kinds of permissions that users can have on that resource. You know, they can read, they can write, they can delete. Here are the roles that I want to exist on this resource. And like, here are the relationships that this resource has with other ones. You know, so, you know, I have a document and it has a parent folder. And so we kind of have like syntax that helps you like specify that, like declare, here's everything I know about my resource. Now that you have kind of like that piece in place, we make it like super easy to write your authorization logic from that. You know, a user can read this document if they are an admin of the parent folder. Like, you literally just write, you know, read if admin on parent. That's simple to write that model. So we kind of give you those like building blocks there, so you can kind of get your core authorization model built out really quickly. So
there's a lot of examples and things like that to start off.
Lots of docs, lots of examples, lots of like, sample applications using this, things like that.
One of the things that you talked about when we were chatting right now was, you need to do authorization at, like, say, every level. Like, it could be right from the UI to the business logic to maybe at the database. So does also do give you like patterns for that as well? Like,
yeah, that's kind of coming back to the enforcement APIs I was talking about. It just kind of provides some more context for folks listening in. Something I think people often overlook with authorization is just like how far it can spread through an app. Authorization done really well should be bubbled up like all the way to the user interface. So you're going through the website, you're trying to do something, and maybe the button is grayed out and you hover over and it says like, only admins can delete this. That right there is like your core authorization logic that's been like presented all the way up to your user. I think the worst people have seen of this is you try and do something and you get some like horrible pop-up, like, you can't do this, talk to your administrator. You're like, what? This becomes like a really interesting challenge with authorizations. It's like, you want to apply best practices and like decouple it and keep it separate from your business logic, but it's so pervasive. Like, how do you solve that? The way we let you do that with Oso, so you express your logic in this policy language, and that's it's by itself kind of separate from the app. But when you need to integrate with the applications, we have like different APIs at different layers. So one that's useful for the front end is you can ask Oso for like a list of all the things a user can do. And then you can like return that to the front end and use it to like make UI differences. The core one is basically just authorizing, can a user do this thing or not? But then we also have, things like an authorized query API, which basically allows you to get your policy, your authorization logic, your authorization policy expressed as like a database filter. So instead of just saying, can the user see this one thing, you say like, what are all the things this user can see? Mm-hmm. And I'm actually then going to go make that as a database query. I'm going to let the database handle the heavy lifting of like filtering down my, 10 million records down to the 5 the user can see. Something that people often overlook, but to do that well requires you to have a system that is like aware that it needs to be used in all those like multiple different places.
I was actually going to ask you some stuff on filtering, but maybe I can ask that now. So specifically this, because, we talked about having authorization at every layer. I think, this latency becomes a big problem, getting huge amounts of data and then what do you present to the user, right? What can also help with this? Do you have any sort of filtering specific tips and tricks? I don't know. Do you have a filtering query language or something like that?
So what we have is, without wanting to go too much into the weeds of this, we sort of have an API that allows you to say, instead of passing in a concrete object and saying, can the user see this? You basically just tell us like the type, the resource type, the document. You pass in the, arguments being like user, maybe the string read and this type document. And basically when Oso goes and evaluates the authorization logic you wrote in the policy, it goes through and basically instead of like concretely checking, what are the fields on this resource? It kind of just like accumulates those as a set of filters. And it can do this across like pretty complex expressions, right? So the, expression it gets back might be, yes, the user can see all documents that belong to a folder where the user has the admin role or the member role on that folder. We do have like an internal representation for that does look kind of very similar to, at least in the latest version, looks quite similar to like a relational algebra, like a SQL kind of thing, but it's mostly just like an internal thing. And then we basically have an API that allows you to kind of hook that up to your data models. So that typically is very easy to do with something like an ORM, but we're also making it possible to go like direct to SQL with that. The kind of core points is, we sort of return this intermediate expression that like kind of looks like a data filter, but we have like an API to hook that up into existing data models. The idea being that you basically get to do this like rich, complex authorization, what are all the things I can see, but your application data like stays exactly where it is. And this is kind of the big like conceptual difference between Oso and like a Zanzibar. So what I was describing in Zanzibar, as a developer, you're responsible for basically migrating and moving all of your data, all your application data into the central service. It's very convenient to do that because now it's like, well, now my data is structured so I can do authorization for you. We kind of push ourselves. We challenge ourselves to say like, actually, I think we don't need to have to deal with migrating, synchronizing data. Data should stay where it is. That's the easiest way to be able to make like dynamic, up-to-date decisions. So instead, we're going to do that work of like figuring out how do we plug in and integrate with your database.
Okay, it's interesting. So you also will actually tie in with any of your data models and your database and provide you this query processing. I guess that's again something that you have to actually look at it. Okay, that's great. I think, and I guess there are many examples on the documentation on how you could do this, right?
Exactly. Yeah. What can be really nice about this as well is it also sometimes lets you do like your data fetching and your authorization in one shot. Because like typically you're going to need to, you get the request, you pass the parameters, you go and fetch some data from the database. We actually make it possible to, in that one go, fetch the data from the database and apply the authorization logic while you're doing it. And so kind of the authorization overhead there is just the kind of like extra query parameters. There is no like separate latency piece needed, which is quite nice.
Okay, interesting. So you're saying that, there could be, I think latency will not be an issue if you tune the parameters correctly, is what you're saying.
Mm-hmm. Yeah.
Okay, you've built this whole authorization logic using your declarative languages that are called Polar, and then you've got it implemented. How do you check if this is the right behavior? Do you have any testing framework that can check that it's doing the right thing?
Yeah, so typically people just use the existing built-in test frameworks in whatever language and framework they're using. The thing that's particularly nice about it, because what the approach does is decouples that logic from the application code, it's basically very easy to unit test your logic. Because you can just write a test that says, create a new dummy user, make them an admin, and then check they can read a thing. And if that works, the application logic is going to work too, because they're using the same methods, they're using the same APIs. It basically makes it very easy to kind of do that sort of unit testing logic. It is something, though, that we want to kind of work and develop on more, is actually go beyond that and be able to let you sort of do kind of like property test style things where you say, I want to check that a user must have some role to be able to access this kind of resource or something. We can just check that over the policy itself. As sort of a step towards that, like now we've basically been adding a lot of sort of validation checks to our policy right now. So, we'll tell you if you've tried to assign permissions to a role that doesn't exist, or if there's a permission that doesn't have any roles assigned to it, or you're missing a piece of logic. Like we'll give you those kind of like built-in verification checks to make sure you get it right.
Mm-hmm. I should have asked you this in the beginning, but one of the things that is plaguing me at work, and I don't know if this is a problem with a lot of people, is there a good rule of thumb on how many roles one can have?
That's a great question. I'd say as few as possible. As few as possible. We spoke around like very high level, like what role-based access control is, but I think the thing that's like really important to do with role-based access control is it's effectively a way to communicate to your end users like what they should expect to be able to do inside an app. And that's often pretty clear in like an admin member world. Maybe like admins can invite other users, admin can rename the organization, they can delete the organization, and members can typically use the app, do the things they need to. Roles work really well when they communicate to an end user like what their responsibilities are inside an application. I think GitLab, the version control development platform, has like some really nice examples of this where they have guests, they have like reviewers who can review, they have like moderators who can moderate and update, and maintainers who can maintain the code. It's, those names, like they kind of tell you what you should be able to do. A mistake people often make is they just keep on adding more and more roles to try and address more and more different use cases. And like you end up with these giant matrices of people trying to like figure out what they need. Often the answer, if you're finding that you're trying to add more roles, I actually find often the answer can be adding more data model structures. So for example, adding things like teams or projects, because then like users can, they kind of get a little bit more control of that themselves. They can create a sales team project or something. They can add a bunch of resources into the sales team folder, and they can give, the head of sales admin access in just that folder. And then that person can't go and see like legal documents in a different folder. Adding that is very intuitive. It's very natural for people to understand that. It's kind of an easy way to go about it rather than try and preempt those and build them as like a bunch of roles yourself, basically.
I do know that there was this one project that I was working on where they had so many roles that when one person had to onboard a new user, they didn't know what to do, and they just went and gave them system admin because that was the one they could understand. Yeah, so yeah, don't want to go
sounds
there.
About right.
Yeah. Anyway, now that we've covered a few of these things, I want to get into a bit onto the deployment and say consistency part. So now that you have this authorization service, so from what I understood is you can have it embedded into your application or have it outside. But what is the thing? Should it be a separate service so that you can scale it up and down and things like that? Or
I think it sort of depends. We sort of have like a bit of a golden rule at Oso, which is you should build authorization around your application, not the other way around. So doing something like a Zanzibar where you pull all of your data outside your application, or you refactor or migrate all your applications to use a specific authorization system, to me is a little bit of an anti-pattern, because you're basically pushing so much of the work onto the developers to understand how to use the system, how to synchronize with it, and things like that. I think there are ways you can kind of mitigate and lessen that, but generally speaking, I think you should let like the shape of your application drive how authorization works. Practically, how we often see that playing out is it's very, very common for people to have like a central user management service where, users can get assigned to organizations and roles within it and projects and things like that. Because that's just typically how like the application got structured out. And then the individual applications are built inside their own services and things like that. Those services need to get that roles data to be able to make an authorization decision, which is kind of a form of centralization, but it's using the existing structure that is inherent in your app. You're saying, okay, well, we have a user management app. Basically, what do we need to do to make it so that other applications can use that for authorization decisions? How do we get the roles from that service? And that basically allows you just to keep the structure of your application as it already was, to have the same separation the architecture you were going with, and basically figuring out how to make that work. I think basically where the rubber meets the road of that is at certain scales, that in itself does become a challenging problem. Like it's not just whatever, you just scale that one app up. And it does reach a point where you do need like the sophistication of something like a Zanzibar to make that service have that low latency, to have that scale, to be able to process that much data. The point is like you identified that based on the size and the scale of your application, more so than just like you do it because of authorization. And like clearly Google reached that scale. I think there's been a few others, Airbnb, who've similarly reached that scale and are like, okay, this is becoming a huge bottleneck in our application. Like we need to like solve this problem. To me, that's kind of the right way to approach it, is like you sort of see where your application grows naturally and like what shape it's taking. And once you see that is a bottleneck, you look for the appropriate technology to address it.
Data plays a big role in finding that out, right?
Data plays a huge part in it. Yeah.
There are also these other authorization services, like I think Ori is what I saw, which also seems to be built on Zanzibar. And I see a lot more. How does Oso differ from other services like this that you see on open source platforms like GitHub?
The conceptual difference of where does the data go? Where does the data live? With Oso, we went to great length to let you keep the data where it is and figured out how to do authorization around your data, basically like using your data living where it is. A lot of some of the newer solutions coming through based on Zanzibar, they all work as a separate service. So like, Ori is no different. You need to put all your data into the service so that it can do some of this authorization stuff. There's kind of an interesting landscape of solutions because there's been a long history of existing authorization libraries that tend to be for specific frameworks. Like I think, Rails has often had a pretty rich history of like good authorization like libraries that integrate with Rails that could do various pieces of this, or frameworks that very much focus on like role-based access control, but not much else. I think what we're seeing from like Oso and others is really trying to tackle the kind of authorization complexity, like the scaling problems that comes with doing more complex models that gives you more granular control, more granular access control, things like that. So I think that's like kind of the main trend we're seeing from a lot of these newer ones. In some ways, we're kind of trying to stick with the tried and tested approach of keeping it in the app versus kind of, I think, others which have sort of seen Google and being like, well, maybe we should do what Google does.
I also tried one of the libraries that you have supported on GitHub. So I tried the Node.js version. I tried Python. And then I saw that you had no .NET support. Maybe you don't have so many people programming in .NET. So I just wanted to ask you, why is that?
We've had so many requests for .NET support, actually. It's almost certainly the next one we'll get to. The challenge is we did build and design Oso so that it could be like easily, a lot of the core of this is built in Rust and is shared between the multiple different libraries so that like, adding a library isn't, like linear amount of work. It's like, sublinear, like small amount of work to add each library. But I think what we've been struggling with is we've been kind of iterating a lot and making a ton of improvements to the individual libraries that we've already sort of started putting more efforts into like a few of them. So in particular, like Node, Python, and Go, I think again, a lot more of our attention recently. A lot of the newer stuff we're trying out there first rather than trying to do like 6 things simultaneously. if we did .NET, we know that we wouldn't be able to like keep it up to date at the kind of the latest and greatest Oso version. So we're sort of waiting for some of the new features to settle a little bit before expanding out to other languages so that we can kind of like release with sort of a mature feature set.
Mm-hmm. So it's in the pipeline.
It is, yeah, actually, it's highly requested. We have a GitHub issue to track it. That's
okay.
I think is the most highly upvoted issue on GitHub.
Okay.
So we're definitely aware of it.
Yeah. Finally, I guess I had to ask you about the choice of language that you've written Oso code in, which is Rust. Could you just talk a little bit about it? Why did you choose Rust for writing Oso?
One part is I just think Rust is a real pleasure and a real joy to develop in. In particular, like the tooling around it, the developer experience around it is fantastic. Like the error messages from the compiler are very, very useful and they guide you in a good way. It's got like a good linting system. The package management is very easy and things like that. So I just think it's kind of a joy to program in. From a more technical perspective, the advantages it offered aligned very nicely with what we needed. So, number one, we're building something that's like on the critical path for security. So, being performant was important. Protecting against memory vulnerabilities was like a huge bonus that it would offer. Being able to write something that we had like fine-grained control over that was pretty low level, like all that was like very compelling benefits that it would offer. And then the thing that sealed the deal really was that we knew we wanted this to be something we would embed in multiple languages. The most natural way for us to do that would be to have some kind of a C API, C interface. As soon as you need that, that really limits your options down to a few different things, and felt like kind of Rust was like the best of the bunch for doing that. One other thing as well was, which is very convenient and nice from like the runtime models, because this kind of just compiles down to effectively like a system library. It's kind of how it basically looks under the surface. There are no like background threads. There's no runtime. There's no extra processing, deadlocks happening. Like none of that stuff's happening under the surface. It's like Oso only executes when you've told it to do something. And if you're doing something, it does nothing. It's just, it's not blocking or consuming resources, or there's no garbage collection or anything like that. It's just very, very, very predictable. You kind of know what it's going to do. You're not going to see bizarre like latency spikes and things like that.
Okay. Interesting. I think so. That's on one of my bucket lists to learn Rust. So I think that, yeah. This has been great. Before I let you go, Sam, I just wanted to ask you one final question. So to sum this whole conversation up, are there any like some 3 golden rules that you would say for building a consistent authorization system or service?
The number one rule of authorization is you're building for your end users, first and foremost. Like that is kind of why I love this area as well. It's like, I think the end user experience should be what drives a lot of the decision making here. Like what is ultimately building products? That's kind of the main thing that matters. And so that I think just kind of leads you to think around like what is going to make sense to the user. Is it about roles? Is it relationships? Like how would you explain this to a user? And I think basically models help you have like a consistent version of that on the back end. We spoke about like architecturally, building authorization around your application, not the other way around. To me, that means primarily, leaving the application data where it is, being able to reuse or repurpose what you already have, so you're not duplicating effort. Your application is already capable of fetching things from the database. Your application already has a way to determine if somebody belongs to an organization and has a data model that says that. How do you make sure you can reuse that inside one app or across like multiple applications? How are we distributing data across our architecture? That's how authorization should be distributed. I think number 3 is something we haven't really touched on yet, but such a huge part of this is the developer experience as well. Authorization is an interesting one. It's that like, at a bigger team, you're going to want your security engineers like helping audit your code, check that it's all correct. But ultimately, like authorization is so interwoven in the application that you're going to want that developer experience to be good. It's such a core part of it. And so that means, providing them something that's easy for them to work with, that's easy for them to update and modify. One that comes up a lot, it's like if a developer is adding a new feature, they add a new endpoint and they need to be able to check, make sure they add a new permission that the user can do this thing or not. You want that to be like instinctive and intuitive to them. You want them to be able to test that locally, to figure it out, to kind of get that working. You don't want it to be like they send some PR off into the void where it gets like reviewed by some person 3 weeks later and comes back to them. Or like, if the permissions break in production that they don't know why, like it's a really crucial thing to get right. And it it forces you a little bit to reevaluate how you think around like who owns the authorization code, basically. I think what goes hand in hand with that actually comes back to the first point, which is, developers are the ones building, they have the context of the product, they're the ones building the product features, they hopefully are geared in on what the users want. And so like empowering them to be able to make good authorization decisions kind of like connects that full circle,
That's great. It's very well put together. So thank you so much for coming on the show.
Thank you for having me. This is fun.
This is signing off, Priyanka Raghavan for Software Engineering Radio. Thanks.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.